and welcome to a new topic in groundwater pollution and engineering course. So for this new topic, you are going to learn about the source and impact of groundwater pollution. Basically, groundwater contaminations or groundwater pollution occurs when man-made products such as gasoline, oil, road salts, and chemicals get into the groundwater and cause it to become unsafe and unfit for human use. Materials from the land surface can move through the soil and end up in the groundwater. For this topic, there are three learning outcomes. So there are three parts. So first part, we are going to focus on the groundwater vulnerability analysis. And the second part, you are going to learn about the common sources of groundwater contaminant, their prospective behavior and effect on groundwater quality. And the last part is to understand the general movement of groundwater contaminants and how sources of contamination may be identified in real situation. So let's focus on the first learning outcome, which is to understand and be able to apply groundwater vulnerability analysis. So what does it mean by groundwater vulnerability analysis? Groundwater vulnerability is a term used to represent the natural ground characteristic that determine the ease with which groundwater may be contaminated by human activities. Groundwater is vulnerable to contamination from a wide range of human activities. The vulnerability of an aquifer depends on the characteristic of the aquifer itself, as well as those of overlying rocks and soils, and also the thickness of the unsaturated zone, plus with the properties of any pollutants. Talking about groundwater pollution or contamination, so what is the difference between these two terms? Contamination is simply the presence of a substance where it should not be or at concentration above background. However, pollution is a contamination that results in or can result in adverse biological effect to resident communities. Since this time, numerous methods have been developed for groundwater vulnerability assessment. They can be categorized into four groups. First, overlay and index-based methods. The second one is process-based simulation models. The third one is statistical method, and last is hybrid methods. Index overlay method is the most widely used among the methods of groundwater vulnerability assessment because of simplicity in use, less data requirement, and clarity in description of the vulnerability. Overlay analysis is a group of methodologies applied in optimal site selection or suitability modeling. It is a technique for applying a common scale of value to diverse and dissimilar input to create an integrated analysis. Suitability models identify the best or most preferred location for a specific phenomenon. A process-based model is the mathematical representation of one or several processes characterizing the functioning of delimited biological systems are fundamental. Within groundwater vulnerability in particular, statistical methods are used to support decisions about environmental planning and management. This slide shows some of the parameters used in selected overlay and index methods for vulnerability assessment. The overlay and index method are used for combining maps of parameters considered to be important in contaminant, where each attribute is assigned a numerical score based on its perceived importance. This method relies on simple mathematical representations of expert opinion rather than process representation or empirical data. Their major negative aspect is the fact that assigning numerical value to the descriptive entities and relative weight for the different attributes is very subjective. One of the examples of developed overlay and index method is drastic. Drastic is a model that considers the main hydrological and geological factors with a potential impact on aquifer pollution. Its acronym stand for D, depth to groundwater, R, recharge rate, A, aquifer, S, soil, T, topography, I, weather zone, C, aquifer hydraulic conductivity. A high drastic index corresponds to the high vulnerability of the aquifer to pollution. In the drastic index, each parameter is rated on a scale from 1 to 10 that shows the relative contamination potential of that parameter for that area. The overall drastic index is established by applying the following formula as shown in the slide. R and W are the rating and weight of the respective factor. Here is the rating value for each of the drastic element. This is the standard used in Malaysia for national water quality standard. Based on the National Water Quality Standard and Water Quality Index, the Department of Environment (DOE) has classified water into a few classes such as class 1, 2, 3, 4, and 5. To measure the quality of water and detect the water pollution, it is one of the indicators that can be used as shown in the table.